This is St. Louis on the Air from St. Louis Public Radio. I'm Elaine Cha. In the year 2029, NASA plans to launch a small satellite into space that will orbit the Earth. The $20 million Landolt Space Mission's goal is to help scientists calibrate telescopes to more accurately measure the brightness of stars. The mission is named after Arlo Landolt, a renowned astronomer who put together catalogs of stellar brightness. Landolt, who died in 2022, was born and grew up in the Metro East. In a moment, I'll talk with one of his daughters about her father's upbringing and legacy. But first, producer Alex Hoyer had a chance to catch up with the principal investigator of the Landolt Space Mission. Peter Plavchan is an associate professor of physics and astronomy at George Mason University. Alex first asked him why the mission is necessary.
The long story short is that I can point at an arbitrary star in the sky and I can see it change in brightness with the Webb Space Telescope or the Hubble Space Telescope by as small as 10 parts per million. It's a fraction of 0.001% changes. But if I then point at that same star and ask how many photons per second are coming in, like the physical amount of radiation coming from that star, I can only give you an answer that's accurate to about 2 to 3%. So that's a little bit of a technical explanation as to why we're doing this. But there's a huge knowledge gap between our ability to measure changes and to measure the values themselves of how bright stars are.
What are some of the practical reasons to be able to better measure the brightness of stars?
Yeah, so our mission has three main science cases. The challenges that we are limited to in measuring the brightness of stars turn out to affect our variety of our understanding of the processes that go on in our universe. For example, it turns out our ability to measure the brightnesses of stars limits our ability currently to characterize the amount of dark energy in our universe, which is thought to drive the acceleration of the expansion of our universe, something that was discovered 100 years ago by Edwin Hubble. And it also turns out that we know how to describe stars and their lives fairly well. And so for a star younger than about 1 billion years old, which is a young star for comparison, our sun is around 5 billion years old. For stars younger than about 1 billion years ago, we have all sorts of tricks to figure out how old that star is. But from when a star is about 1 billion years old to about 10 billion years old, it turns out it's really hard to estimate the ages of distant stars. And the limiting factor is our understanding of their brightnesses, because the stars change very slowly over that time frame from 1 billion years old to 10 billion years old. So if we want to understand the kinematics, the motion of the stars in our galaxy and the evolution of planetary systems, we need to know more precise measurements of the brightnesses of stars to be able to determine their ages, their radii, and their masses to a level we haven't been able to do so before. The third science case of the mission is understanding the habitability of exoplanets. So we measure exoplanets. We've discovered over 5,000 exoplanets. These are planets that orbit other stars besides our sun. And they're incredibly abundant. We know that roughly 1 in 10 sun-like stars has an Earth-sized planet that could support life if it has an atmosphere and if it has water. Of course, there's a lot of gotchas on that. But we know that Earth-sized planets are relatively common in our universe. So what defines exactly Earth-like? Is it too hot? Is it too cold? Well, in order to understand the activity going on a planet like the Earth, its characteristics, we need to understand a star pretty well. So it turns out understanding stars affects our understanding of other worlds as well.
When this artificial star is in orbit, how big will it be and what will it look like? Like, is it as big as a school bus, bigger, smaller?
So the NASA Landolt mission is part of what's called the Astrophysics Pioneers program, which is a new program within NASA. It's only about 3 years old, where they're looking to train the next generation of space scientists and space engineers. And a lot of scientists and engineers grew up building these very large missions for NASA and defense and the military and other communication satellites. And those were very big satellites, right? The sizes of buses, the Hubble Space Telescope being a great example of that. The Landolt mission is actually going to be tiny by comparison. It's measured on what we call the CubeSat system. So it's 12 units in size, where each unit is about 10 centimeters, which is about 4 inches on the side. So if you imagine a 4-inch by 4-inch by 4-inch cube and 10 of those, that's about how big our satellite is, or about the size of a microwave. And so it's going to be a pretty tiny satellite, but it's going to be equipped with some pretty decently powerful lasers for space-based qualifications anyway. So those lasers will shine down on ground-based telescopes, and you won't actually be able to see it with your eyes. I know there's all sorts of conspiracy theories out there where people shine, they think that the people shine lasers down on the Earth. These lasers will be so dim, you will need a telescope to see them. Even with your eyes, you won't be able to see them. For comparison, there are satellites out there that you can see with your eyes when they reflect sunlight. So it won't be any concern to any natural wildlife or human health. It'll just be visible by extremely sensitive detectors we have on today's modern telescopes.
That's Peter Plavchan, the principal investigator of the Landolt Space Mission and an associate professor and executive director of the Mason Space Center at George Mason University. He talked with producer Alex Hoyer. The mission aims to launch a small satellite into Earth's orbit in 2029 to help scientists calibrate telescopes for more accurate measures of the brightness of stars. The mission is named after Arlo Landolt, a renowned astronomer who worked at Louisiana State University and put together catalogs of stellar brightness. Landolt passed away in 2022. Last week, I talked with one of Landolt's daughters, Jennifer Boutte. She's a chemistry instructor at St. Louis Community College, Forest Park. Jennifer, your father was born in 1935, and he was a farm kid who grew up in Madison County, that's in the Metro East, near Highland. What is it that you know about what his childhood was like?
Well, he was the oldest of 4 children, raised on a farm out, as you said, near Highland, close to the Grand Fork, Pocahontas area. And he, I know that he went to a one-room schoolhouse for the first 8 years of his education. And because they did an accelerated program, they could, really kind of work at their own pace at those types of schools. He was able to finish early, and then he attended high school in Highland itself. And he started that and he was able to graduate that too, then more quickly. And he graduated from there when he was 16.
Mm-hmm. And where did he go thereafter?
So for his undergraduate degree, he went to Miami University in Ohio, where he studied math and physics for his undergraduate.
Mm-hmm. And then from there went to
then
other
he
places.
Went to Indiana University in Bloomington for his PhD. Mm-hmm.
So the obituary of your father, speaking of what his school experience was early on, the obituary notes that he attended a one-room country schoolhouse, and it was about a mile from home, where 8 grades were taught by one teacher. On cold winter mornings, his mother would send him to school with a baked potato for each pocket to help keep him warm. Maybe they would have been snacks at some point.
Could have been part of lunch, yes.
Right. So maybe it is not that story, but is there another about how he grew up that perhaps stands out to you, maybe something that prefigured what he would end up doing?
I know he was always very interested in nature and therefore science. I know he participated in the 4-H club when he was youngster. I don't remember for sure if he showed like sheep or cows or pigs, but I know he showed some animal like that. But I know he was always very involved in nature and always had loved talking about, different plants and flowers. He gardened his whole life, very interested in different types of trees and bird watching and that type of thing.
Was that part of your childhood too then?
Oh, yes, definitely. Yeah. Yes, always helped him out in the garden, and he got me into bird watching, and he always had his binoculars close by the main window in the house where he could double check what was flying around outside.
And we did talk about bird watching very recently on the show. There was also something that he did that maybe not as many people know about, and this happened before he began his career in astronomy. And it has to do with a trip very far away.
Yes.
Tell us about that, Jennifer.
Yes. So when he was in graduate school, he started that in 1955 when he was only 17 years old, is when he started graduate school.
Oh, wow.
And actually, I'm not sure. That might have been 19. I think it was at 19. But he was doing well his first year. But he had always said that there was, maybe a little something missing. He wasn't sure if it was exactly what he wanted to do. And he found out about an opportunity to work at the South Pole as part of a group that went down for the first International Geophysical Year that was to take place between 1956 and 1957. And many countries had different groups that went. And the United States sent a group of 9 scientists and 9 Navy Seabees who were responsible for the maintenance of the facility. And he was part of the first overwintering party in Antarctica from 56 to 57. And he studied the southern lights, the aurora australis down there, and the air glow. And he always, I think that really influenced a lot about how he learned to deal with different types of people, and he learned to really give good presentations, and he grew up a lot down there. He turned 21 while he was down there.
Wow. Were there any photographs from that time?
There's actually, the whole thing was written up in National Geographic in one year in the late 50s, early 60s. And the project leader of the group, Paul Seipel, wrote a book called 90 Degrees South. And that's all about the experience that the group had down there.
Is that part of a family collection?
Oh, yes. Yes. We have several copies of that book.
So, Jennifer, you grew up in a pretty large family. It was a blended family. Your father, Arlo, became reacquainted with and then married a high school classmate who is your mother, Eunice Casper. Now, your mother, who is still living, had 4 daughters already, ages 6 through 10, when they were married. And a few years after that, then came you, the baby of the family. What was your upbringing like in a family of that size? And as I understand, your mother was a nurse.
Yes.
How did all of that sort of affect what family was like? It was a wonderful family experience that we had growing up.
My dad was a professor at Louisiana State University. He started there in 66 and continued until only like a year before his death. He was still going in every day as a professor emeritus. As you said, my mom was a nurse. She was a school nurse. About the time I think I turned 9 or 10 is when she kind of started working more regularly again, having to raise 5 daughters like that. It was wonderful. There was a lot of camaraderie. We talked about nature and science. My mom being the nurse, all of those types of topics were talked about. Of course, it was chaotic with 5 girls, all girls in the family. My father tended to just keep his head down and go with the flow of things, I think, in some regard.
One of the things I thought about with that many daughters and that many people in the household, did your father have a nickname for the constellation of you all?
My parents tended to number us. So if the phone rang, they would yell out, phone call for number 2.
Oh, my goodness.
That's how they kept track of us.
Yeah. Jennifer, to what extent did your father, Arlo Landolt, bring his work home or talk about what he did maybe around the dinner table or when you were spending time together in the backyard or bird watching?
So at home, honestly, it really wasn't a huge topic for the science itself. Of course, he spoke a lot about maybe what was going on at LSU and in the department, and a little bit about his research trips. He used to travel to Chile to observe down there, or to Arizona and observe there as well. But I hate to say it, but most of us were not terribly interested in astronomy as careers for ourselves. So we did not pick up as much astronomy as probably would have been nice at this point in life to look back and say, I wish I would have learned more about something from him along those lines. But I did used to go with him. LSU used to have a small observatory and about 45 minutes, maybe an hour outside of Baton Rouge, Louisiana. And I would go spend time with him there. He would be observing, and I'd play in the dormitory area, and we'd spend the night there. And I got to experience that a little bit. He'd let me move the telescope around a bit, and I could ask questions, and he was always wonderful to share information with me. I probably just didn't ask enough questions looking back.
Have you been back to that observatory at LSU since the time you were a child and went with him?
Unfortunately, they closed the main observatory probably in the late 80s, early 90s. There is one on campus still that they have now named after him. But it's not, because it's in Baton Rouge itself, it's not used really for major observation research. It's used, opens to the public maybe once a month type of thing to show.
So you said that among the sisters in your family, no one has pursued astronomy, but you are a professor of chemistry at St. Louis Community College, Forest Park. To what extent then would you say your father's work maybe influenced the path that you decided to pursue?
Since we always, again, talked about nature and science in general, and my mom, health type of science, it was always a big topic in the family. So that definitely brought me into science as a career itself. And he was very well read. He would read not only many, many different types of science things, but he was interested in history and biographies and things. So we always, I think that influence of education was just always present and helped guide me into a science area.
Speaking of education, we heard a little bit earlier from Peter Plavchan, the principal investigator of the Landolt Space Mission. And Jennifer, I'd like you to hear some of what Peter Plavchan said.
Arlo was a quintessential professor. He loved working with students. He loved mentoring his junior faculty colleagues at Louisiana State University. And everyone just remembered him with extreme fondness when he passed away. And it was right about the same time as we were proposing this mission. So it just made perfect sense to kind of honor his scientific legacy with this small gesture of a small mission in orbit.
And that was Peter Plavchan. Again, he's the principal investigator of the Landolt Space Mission. What is your reaction to what we've heard from Peter just now?
I'm not surprised. My dad he loved his teaching. He loved, interacting with other scientists and people interested in those areas. Reading comments left after he passed, people posted, comments on different boards and through his obituary and things. Many times you'd hear people say, "Oh, Arlo was so nice. When I was a student, he sat down and talked with me at one of the big national meetings and made me feel included." And he was always communicating with people, writing letters back in the day when it was actual letters, and just reaching out and continuing that mentorship and just his interest in people and their interest in science.
How did you find out that this mission was being named in your father's honor?
I believe it was through the chair at in the Department of Physics and Astronomy at LSU. I believe he had first sent something to my mother, and then she shared it with the rest of the family.
And how did it feel? I mean, what was your collective And your individual reaction to getting that news.
Oh, we were just thrilled. He's always a very humble person, and I think he would have been tickled to say that just describes how he would react, that he would be tickled and very pleased with that honor.
Mm-hmm. Was there ever a moment, Jennifer, where you realized the magnitude of your father's contributions to astronomy?
It probably really wasn't until maybe late high school, college, that I really understood that he had had such a large impact. I knew he had won an award for being, I think it was the longest running secretary of the American Astronomical Society. He did 3 terms of that. I knew he was very involved in things, but I don't think I really understood the impact his research had had and until I was much older. He's probably best known for his Book of Standard Stars, they call it. It's the Landolt Photometric Standard Star Catalog. And that I think I saw the percent of 10% of astronomers use this data to help them with their calibrations and their research. And it's one of the most cited scientific papers in the astronomy field. And so until I really understood that and I was really pursuing science myself, I didn't understand what that meant.
Mm-hmm.
Yeah.
Jennifer, it's been about 3 years since your father passed, and you said up until the year before he passed, he was still teaching. So
he wasn't teaching, but he was still researching and
he was still
going
researching.
into campus as a professor emeritus.
Mm-hmm. Mm-hmm. What do you think he would think of this mission? And then it's being named after him.
Mm-hmm. I mean, I think he again would have been tickled with being named after him. And I don't know the science behind the mission a lot myself, of course. But I know he would have been honored to have been a part of that and excited to see what type of research and data would be coming out of this satellite that they're going to be putting up in his name.
That was Jennifer Boutte, a chemistry instructor at St. Louis Community College, Forest Park, and the daughter of Arlo Landolt. The prominent astronomer from Louisiana State University was born and grew up in Madison County. The Landolt Space Mission, that seeks to put an artificial star into Earth's orbit in 2029, was named in his honor.
This episode was produced, recorded, and edited by executive producer Alex Hoyer.
Podcast design by Aaron Dorr.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations. And leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thanks.
St. Louis Public Radio is a member-supported service of the University of Missouri St. Louis.
The Gateway brings you the day's news each weekday from around the St. Louis region and the state capitals in Jefferson City.
Our schools are accredited. We don't need this bill.
And Springfield.
How many more years must pass before lawmakers see time is of the essence?
I'm Abby Larico. Join me each weekday for The Gateway on the STLPR app or wherever you get podcasts.